Okay, good afternoon, students. So let us move to the next theorem, reciprocity theorem. What is a reciprocity theorem? But here always the two sources, one is voltage source, another one is a current source. Voltage source in series, current source in parallel. Both the source will be ratio. In any linear network consisting of linear and bilateral impedance of active sources, ratio of voltage V introduce one loop to the current I in another loop. It means the voltage is a one loop, the current is another loop, voltage V is introduced one loop, current is another loop, is the same as ratio obtained the position V and R interchange. Suppose interchange V and R in the same answer because of the V is introduced one loop, the current I is another loop, same ratio is obtained position V and R interchange in the network. While calculating the ratio, sources other than one which considered to obtain the ratio must be replaced by the internal impedance. Even though internal impedance will be changed V to I, the answer should be same. That is called the statement of reciprocity theorem. Okay, the next explanation of reciprocity theorem. V is a voltage source loop 1, I is a current is loop 2. This is a V, one loop, I is another loop in between the internal impedance. The reciprocity theorem states that ratio of V and I remains same. The position of V are interchanged in the network as shown in the figure. The second diagram, just interchange V to I. The V is the left side, but here V is the right side. The current just interchange, this is a current, this is a voltage. In other words, V and R mutually transferable. The ratio V is also called as transfer impedance, denoted by Z12. The mutual intertransfer V and R, that is a transfer impedance, is denoted by Z12, where V is a voltage introduced in the loop 1, I is a responsible due to V in the loop 2. Okay, proof. Sometime ask in the exam, state and prove that reciprocity theorem. Sometime ask in the examination, main examination. Just write down the statement and proof also. Consider the network. But here the current is one side. V first the V source. Next current, that is I1, I2, in between the internal impedance Z1, Z2, Z3. Applying KVL to the two loops. Here the ratio calculate V1 by I2. Applying KVL to the two loops. That is I1 Z1. Next I1 is common, minus I1. Sorry, Z3, I1 minus I2. I1 minus I2. Just to write I1 Z1, I1 Z3 plus I2 Z3 plus V1 equal to 0. You write directly. I1 one side, I1 Z1 plus Z3, I2 Z3 equal to V1. The second loop, I2 Z2. Next I2 Z3, I2 minus I1. I2 minus I1. That is minus and minus plus here. Minus I2 Z2 minus I2 Z3 plus I1 Z3 equal to 0. I1 Z3 first minus I2 common Z2 plus Z3 equal to 0. Equation number 2. Just to calculate determinant D, Z1 Z3 coefficient minus Z3 Z3 minus Z2 Z3. Here Z1 Z3 into Z2 Z3 plus minus minus plus Z3 square. Just simplify that. Minus Z1 Z2 minus Z2 Z3 minus Z1 Z3. This is a D. Determinant. Here Z1 minus Z1 Z2 Z2 Z3 Z1 Z3. This is D. Next to calculate Z2. Z1 Z3 Z2, second column we change, V1 0. This 0 directly 0, remaining minus V1 Z3. It means that I2 equal to D2 by D. What is D2? Minus V1 Z3. What is a D? This whole thing, denominators. Okay, just reverse. V1 I2, V1 I2, Z1 Z2 plus Z2 Z3 plus Z3 Z1 plus one side minus outside, minus minus cancel, remaining Z3. V1 I2. The same thing, let us interchange the position V1 I2. The next figure, V1 I2. Previous this is V1, now I2, this is V1 side. Again you write applying KVL to the loops. I2 Z1, I2 Z3 plus I1 Z3, that is minus I2 minus I1 minus Z3 I2 minus I1. You write directly I2 Z1 minus I2 Z3 plus I1 Z3 equal to 0. Here I1 Z3 minus I2 Z1 Z3 equal to 0. This is one equation. The another equation, another loop. So is I1 Z2 minus I1 Z1. Next minus I1 Z3 plus I2 Z2. It means I1 minus I2. Previous I2 minus I1, here I1 minus I2. Right? I1 Z2 Z2 I1 Z2 plus Z3 minus I2 Z3 equal to V1. Again you calculate D, same previous method. Just you write coefficient Z3, Z1 Z3 because of minus, Z2 Z3, next minus Z3. Just simplify that. Z1 Z2 Z2 Z3 Z3 Z1. Next you calculate D2, Z3 V1. The I2 equal to D2 by D, Z1 Z3 V1, D Z1 Z2 Z2 Z3 Z3 Z1. Next V1 by I2, V1 by I2, Z1 Z2 Z2 Z3 Z3 Z1 by Z3. Okay, just problems on reciprocity theorem. Verify reciprocity theorem for interchange V and I, the current shown in the figure. Just given network, just interchange the various branch currents are shown in the figure. Thank you. Shown in the figure. This is minus 2I1 minus 2I1 minus 3I1 minus I downwards plus 10 equal to 0. This is 2 and 3, 5I1 minus outside plus 3I equal to 10, the equation number 1. Second equation, minus 2I upward, current is downward but direction is upward, plus 3I1 minus I1 minus I. This is 3I1, 2 to 3, that is 7, 2 to 4 plus 3, 7. 3I1 minus 7I equal to 0. Just to calculate determinant, 5 minus 3, 3 minus 7. 5 into 7, 35, minus 35, minus plus 9, that is minus 26. This is D. Again D2, 5, 3, 10, 0. 0, 5 into 0, 0, 10 into 3, minus 30. I equal to D2 by D. Here I is nothing but I2, that is D2 by D, minus 30 minus, that is 1.1538. What is the ratio V by I? V is 10 volts. What is I? 1.153, that is 8.67. Now interchange V and I. Previous V and I, here I and V. Here also same answer. Applying KVL, okay, minus 3 I1 minus I. Why minus? Because the downwards. Minus 3 I1 minus I plus 2 plus 2I, that is minus 3I1 minus plus 3 plus 2, 5I1 equal to 0. Equation number 1. Second equation, current is downwards, the loop is this side, that's a plus 2I1 plus 2I1, again minus 10 plus 3I1 minus I. Current is downward but loop is upward, that is plus 2 plus 3, that is 7I1 minus 3I1 minus 10 this side, right hand side, that plus 7I minus 3, 10. Equation number 2. Next D, 3 minus 3, 5 minus 3, 5, 7 minus 3. Minus 3, 5, 7, that 3 into 3, 9, that is 26 answer. D2, minus 3, 7. Next second column we change, 0, 10, that is minus 30. This is 0. Minus 30. Again same, I equal D2 by D, minus 30 by 26, that is 1.15. Again voltage current ratio V by 10 by 8.67. Reciprocity theorem is verified. Why verified? Because of V and I ratio, even though interchange, answer will be same, 8.67, 8.7. Okay, thank you. Remaining next video lecture.